Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
All right, so this problem has a tile falling past a window, and the pieces of information we know about it is that first up, we are on the planet Earth, so the acceleration of that tile as it falls downwards is 9.8 meters per second squared. Now, I hear some of you saying, wait, shouldn't that be negative? But in this problem, everything we're talking about is downwards, both the displacement and the acceleration and the velocity. So I'm going to be calling downwards our positive direction here. Now, it only takes 0.2 seconds for that tile to fall past the 1.6 meter wide window. And this question is asking me how high above the window was the tile dropped? So to really kind of get what that's asking, let's draw a quick sketch. Here's my building, and here is my window. So we're seeing this part of the tile's motion when it enters that piece here. The question is asking us from what height was it dropped? So it's asking us for this displacement here, which the numbers we have in blue have no way of actually answering. What we're actually trying to get to is a way of figuring out how to set up a second of these kinematic problems. Because if I look at a second set of these, parts of them connect between the two. So the blue part of my motion, that tile falling past the window, is just the second part of this bigger problem. And the first part is the part where we have the tile and it falls a distance x. That's what we're looking for in this problem. We know its acceleration is 9.8 meters per second squared. And because the tile was dropped, we also know its initial velocity is 0 meters per second. Now, in order for us to be able to figure out how high up this thing was dropped, we need one more number. And this is the part where these two sides of the problem, where these two sections kind of overlap. The time is separate. It takes a different amount of time to fall past the window than it did from the top of the building. The piece that is the same, though, is when this is falling past the window, whatever its initial velocity was, whatever this v naught value is here, that is the same thing as the final velocity of the red part of its motion, because the tile starts at 0 when it's right here, then it reaches some velocity v right there, which is the final velocity for that first part of the motion, but it's the initial velocity of the second part of the motion. So this problem is really asking us to do two things. First up, we need to figure out what the initial velocity was of the tile when it reached the window. Once we know that, we need to use that to figure out how high above the window the tile had to have been to reach that initial velocity. So for part one, I'm going to keep my color coding the same here, so I'll be working in blue for part one. We don't know the final velocity, but we know acceleration, time, and displacement, and we're looking for that initial velocity. So we're going to be working with our third equation here, that x equals v naught t plus 1/2 at squared. When I plug in my known numbers, we have 1.6 equals 0.2 v naught plus 1/2 at squared, which becomes 0.196. Okay, then when I rearrange this a little bit, we get 1.404 equals 0.2 times that initial velocity. So finally, our initial velocity for this problem comes out to be 7.02 meters per second. So when the tile reaches the window, it is already traveling at 7.02 meters per second. Now again, like we discussed earlier, the purpose of figuring out how fast it was going initially was so we could use that to analyze how high up it had to have been dropped by. So we don't know anything about the time for the red part of its motion, so we're going to use the equation that does not have time in it. V squared equals V naught squared plus 2ax. And when I plug in what I know and what I don't, I'm looking for the x value. I know my initial velocity is 7, or rather my final velocity is 7.02 squared, and that's equal to the initial velocity of 0 squared plus 2ax, or 19.6x. So when I rearrange that and solve for my displacement, we get a height value of 2.5 meters, meaning this tile had to have been that high above the window to travel by it at the rate we saw.